Well, hey guys, ready to do some rotations, our third transformation that we're going to talk about here. And rotations are kind of tricky, which is why I'm actually going to include an additional video to show you physically how I perform rotations and how I got the answers for our work here. So that way you can take that information, put it to good use, do your assignments, those kinds of things, because this is a transformation that can really be problematic for some students if they don't actually physically do the transformation, do the rotation, okay? So rotation's a turn, okay? It spins a figure around a point called the center of rotation. So they have two components, an angle and a direction. So for our angles, they're in the measurements of degrees, and it tells us how far to turn the image. So if it says 90 degrees, we're going to turn the image a quarter turn, okay? If it said 360 degrees, we turn it a complete turn, all right? And then direction, which way do we turn it, clockwise or counterclockwise? And of course, clockwise is this direction, just like a clock. Counterclockwise, just like that. Okay, so you might want to put those in your notes. All right, again, rotations do not change size or shape, so they produce congruent images, and they do not slide or flip, they just turn, okay? So what I want to do now, before we really get into doing rotations, I want to look at example 1 and 2, just see if you can figure out, just by looking at them, okay, whether or not A is a rotation or B is a rotation. One of them is, one of them's not, okay, I'll tell you that much. See if you can figure out which one is. Which one is a 90-degree clockwise rotation? Okay, a quarter turn clockwise. I'll pause for a second, give you a chance to figure that out. Okay, so if you actually took your iPad, as described in the other video, which I will reference here a lot, for especially for this topic and probably the final one, and you spun your iPad, you would have realized that a 90-degree clockwise rotation would be figure B, or problem B. Okay, so this is the right one because the arrow is pointing in the right direction. 90 degrees clockwise, the arrow is going to go this way. If it was 90 degrees clockwise for A, the curved piece would be facing upward. The arced piece would be facing on the bottom. This one's reversed, so it's been another transformation has been applied on problem A. Okay, so A is not a rotation, a 90-degree clockwise rotation on its own. B is. All right. So let's talk about how to do these on the plane. Okay, so on the plane, the center of rotation is always going to be the origin. Now, it doesn't always have to be the origin. In fact, when you take geometry in high school, it could be a vertex of your shape. It could be another point on the plane. We're going to keep this simple. We're going to make it always the origin. Okay? So keep that in mind as you rotate on the plane. All right? Otherwise, if you notice, I have a back up here to page 11 for a second. I have the rotation point right here, so you'll see the point there if it's not on the plane. Okay. All right. So again, plotting the point 1, 3. I'm gonna just start like we've always started before. So plot the point 1, 3 right there. Okay. Now we're going to rotate this point 90 degrees counterclockwise. Okay, 90 degrees counterclockwise. So actually turn your iPad or your paper, whatever you're using to work this on, turn it 90 degrees counterclockwise according to the video that the supplemental video that I sent about how to do these physically. Okay, and if you do that correctly, you will find that you will have the point -3. Whoops, let me switch the pen. -3, 1, right there. Okay, so that is a 90-degree counterclockwise rotation. -3, 1. Okay, now we're going to take the point 1, 3. We're going to rotate it 180 degrees. Okay, And notice I don't have a direction here on this one. If you notice, 180 degrees is halfway around either direction, so there's really no point in having to put a direction on 180 degrees. But there is on 90 and 270. Okay, and we'll talk about those as we advance here through the video. So basically, take care of that. Right now, I'm going to actually pause for a second and give you a chance to do this one on your own. Okay, so turn your iPad with the point 13, 180 degrees, and identify the coordinates, and then plot the point after you revert your iPad back. Plot the point, write down the coordinates. Okay, I'll pause for just a second. Okay, well, if you did it correctly, you would have found that the point would have been -1, -3. Okay, so that is a 180 degree rotation. Okay, and I could have put the arrow going the other way too. I'm just going to be consistent because the next one's also counterclockwise. Okay, speaking of, let's go ahead and tackle that one. So now we're going to do a rotation 270 degrees counterclockwise. Okay, so we're going to take our blue point again, and this time rotate it. Okay, if you do it correctly, I'll pause for a second so you can try it on your own, and then we'll talk about how to do it. So pausing now. Okay, if you do it correctly, you should have found out that it would be the point 3, -1. So 3, -1 right here. Okay, so there's the 270 degree rotation. I'll put it right down here. All right, looking at these discussion questions here. Okay, is there another way to describe a 270 degree counterclockwise rotation? The answer is yes, okay, because I could have gone, if I go up here to the plane again, instead of going 270 counterclockwise, I could have gone 90 clockwise. Okay, so the 90 and 270 can be named both directions. Okay, so 90 in one direction, 270 in the other. All right. Okay, so 90 degree clockwise. Okay, and then we talked about this one already, about 180 being the same both directions. Okay. All right, now this is going to be a little bit tricky, so I'm going to do this one with you. And then you're going to do example 3 on your own. I'm going to save that one for the answer key on your notes, so you can check that one on Canvas. Okay. We're going to do -4, 1. We're going to plot these points. So -4, 1 is right here. -1, 6, right up there. Okay. -1, 6. I did 1, 6. I'm sorry about that. There's -1, 6. And -1, 1 is right here. Okay, so there's my triangle, and we'll get it connected here. Okay, so that's the point A, B, and C. We're going to rotate this figure. Let's straighten that up a little bit here. Rotate that figure 90 degrees clockwise. Okay, and then we'll write down A prime, B prime, C prime down here. Okay, so go ahead and physically turn your image. Okay, so you can figure out the correct coordinates, and we can go from there. In fact, I'll pause for a second for you to figure that out. Okay, so if you do it correctly, here's what happens, okay? I can't show you on this video how to do the turns because it'll mess up the orientation on the video. But that's why they have the additional video that shows all these being done and stuff like that. So pay careful attention to that one. It'll help you out a whole bunch. So if you do this correctly, A becomes the point 1, 4. So right there. Okay, B becomes the point 6, 1. So 1, 2, 3, 4, 5, 6, 1, right there. And C becomes the point 1, 1. So our triangle has definitely turned. That last one's not as straight as I'd like. It's okay. So A prime, B prime, C prime. Okay, let's get them right down here. 1, 4, 6, 1, 1, 1. Okay? There is a symbolic representation for rotations, however, it's pretty complicated to figure it out. Some students do figure it out and use it. It's not something that we have a lot of time to worry about right now, so I'm going to kind of forego that part of it at the moment. So we're not going to worry about symbolic representations for rotations because they can be kind of tricky, all right? So just get the transformation completed on your plane or on your paper, and we're good to go. All right. I'm gonna leave you example 3 to do, okay, right now, and then we'll go over it together. So I'll pause for a second. You plot the pre-image, and then rotate the pre-image 180 degrees, and then find the coordinates of A prime, B prime, C prime, and D prime. I'll pause. Okay, so let's go ahead and get this set up here. So we're going to plot these 4 points first. Okay, so I have the point 1, 2 for A, right there. 4, 4, 2, 3, 4, 1, 2, 3, 4, 4 is right there for B. And then C is 4, 6, that's 2 above 4, 4. And D is 1, 6, that's above A. So there's my pre-image. Okay, and then A is there, B, C, and D. Okay, and we're going to rotate it 180 degrees. Okay, so that means 180 degrees. Each quadrant adds 90 degrees. So if I go over there, that's one quadrant, and then another quadrant would be 180. So this is 90 and another 90, and you add them together, you get 180. Okay, so I'm going to have this figure is going to all be in quadrant 3. Okay, so if you do it correctly, the order pairs are going to be as follows. It's going to be -2, -1 for A prime, -4, -4 for B prime. Oops, there we go. -6, -4 for C prime, and -6, -1 for D prime. Oh, these points, I didn't get them in the right location. These should be down one more. There we go. I thought something was off, that's why I paused for a second. Sorry about that. I think now we're good to go. So connect them, label them. Okay. A prime, B prime, C prime, D prime. So A prime is -2, -1. B prime is -4, -4. C prime is -6, -4. And D prime is -6, -1. Okay? All right. Now, for the next example, okay, I'm going to do only one of these for you, okay? I'm going to do B. I'm going to let you do A. You can check A on the answer key, and I mean it this time. I know I said on example 3, and I went ahead and did it anyway. This time I mean it. I'm actually going to say A for you to do on your own, okay? We're just going to focus on B. And I want you to look at how many quadrants, okay, are between the points. So there's A, and there's A prime. So you can either go the clockwise direction, which is this way, or you can go the counterclockwise direction, which is this way. Okay? So how many quadrants are between those 2 points? If you figure that out, you can get the rotation, because it's definitely a rotation because the turn was made on the figure, from figure 1 to figure 2. Okay? So figure out how many quadrants, okay, are involved in rotation. If you do it correctly, you'll find out that there's one quadrant if you go clockwise, which means you're going to add 90 degrees, okay? Or 3 if you go counterclockwise, which means 270 degrees, okay? So one quadrant clockwise, 3 quadrants counterclockwise, 90 clockwise, 270 counterclockwise, okay? So for B, you could said a rotation 90 degrees clockwise, or, okay, a rotation 270 degrees counterclockwise. All right, that's going to do it for this topic, or this part of the notes, this transformation. These tips on here are very, very important. I'm going to hit these in a other video before we talk about the fourth transformation. So make sure you catch that, because I'm going to show you how to actually physically turn your paper, your iPad, so you can do these transformations correctly and get them right every single time, okay? Because you actually have to physically do these rotations in order to get them correct. I have to do it myself in order to get them correct. So I strongly encourage you to do the same thing, okay? So check out that supplemental video before going on to dilations. It's going to help you out with your assignment over rotations.